Test the convergence of integration 0 to 1 dx by x square. Observe the integrand, that is 1 by x square, and the integration limits are 0 to 1. If I substitute 0 here, then 1 by 0 square is 0. 1 by 0 is infinity. That's why I've written this line. The integrand 1 by x square has infinite discontinuity at 0 belongs to closed interval 0, comma 1. In the next step, integration 0 to 1 dx by x square, I am taking. Now I want to check whether this integration diverges or converges. Here at 0, integrand is having infinite discontinuity. That's why I am writing 0 plus epsilon, and limit is taking as limit epsilon tends to 0 plus. If we have infinite discontinuity at the upper limit, then I am writing epsilon tends to 0 plus 1 minus epsilon, like that. If the discontinuity at 0, then I am writing 0 plus epsilon. If the discontinuity at 1, then I will write 1 minus epsilon. Here I have infinite discontinuity at 0. That's why I am writing 0 plus epsilon. 1 by x square can be written as x square minus 1. Now I am using power formula to integrate x power minus 2. That is x power minus 2 plus 1 by minus 2 plus 1. This is equal to x power minus 1 by minus 1. That means 1 by minus 1 by x. So the integration of x power minus 2 is minus 1 by x. Here I am written the limits are 0 plus epsilon to 1. 0 plus epsilon is nothing but epsilon. 1 is as it is. First I am going to substitute upper limit, then minus 1 by 1. That is minus 1 only. Minus of minus 1 means plus 1. Epsilon I am going to substituting in the place of x. Then I am getting 1 by epsilon. Now I am substituting epsilon by 0 plus. That means 0 only I am substituting. 1 by 0 is infinity. Minus 1 plus infinity is infinity. Here I am getting infinity. That's why it is diverges to infinity. Next, test the convergence of integration 1 to 2 x by root of x minus 1 dx. Here the integrand is x by root of x minus 1 has an infinite discontinuity 1. This 1 belongs to closed interval 1 comma 2. Why I am saying the integrand is having infinite discontinuity means if I substitute 1 here, I am getting 1 by root of 1 minus 1. That is 1 by root 0 is nothing but 0 only. The value becomes infinity. Here 1 present in the place of lower limit. That's why I am taking epsilon tends to 0 plus 1 plus epsilon to 2. Integrand is x by root of x minus 1 dx. Limit as it is. Observe the numerator. I am changing the form of the numerator, but I am not changing the value. X can be written as x minus 1 plus 1. If I cancel plus 1 and minus 1, then I am getting x only. So next I am splitting this fraction as x minus 1 by root of x minus 1, 1 by root of x minus 1. Integration limit same, limit also same. So observe here I have the term x minus 1 by root of x minus 1. This numerator can be written as x minus root of x minus 1 into root of x minus 1. 1 x minus 1, 1 x minus 1 cancel. Then I am getting root of x minus 1. The second term as it is. Now I am going to integrate this term and this term. Here root means 1 by 2. So applying power formula for integration, x minus 1 power 1 by 2 plus 1 divided by 1 by 2 plus 1. Next I want to do differentiation of x minus 1. The differentiation of x is 1. The differentiation of 1 is 0. Here also same formula, but here root of x minus 1 lies in the denominator. That's why if I take this term to numerator, then the power of x minus 1 becomes minus 1 by 2. That's why integration of this term is equal to x minus 1 power minus 1 by 2 plus 1 by minus 1 by 2 plus 1. X differentiation is 1, 1 differentiation is 0. The limits are 1 plus epsilon to 2. First of all, I am going to substitute 2 in the place of x. So, 2 minus 1 is 1 only. 1 power anything is 1. Next here, numerator is 1. In the denominator, I have 1 by 2 plus 1. This is 3 by 2. If the fraction lies in the denominator, it goes to numerator as reciprocate. That means 2 by 3. 2 by 3 into next x minus 1. So this is the simplification of this term is this term. Okay. X minus 1 power 3 by 2. 3 by 2 goes to numerator as 2 by 3. Here 1 minus 1 by 2 is there. 1 by 1 by 2 is 2 only. That's why 2. 1 minus 1 by 2 is 1 by 2. 1 by 2, if one any term having 1 by 2 as power, then this can be written as root of minus 1. Here I am substituting limits. First I am substituting upper limit. 2 x becomes 2. 2 minus 1 power 3 by 2. Here also I am substituting 2. 2 minus 1 is here 2 minus 1. Now I am going to substitute lower limit minus 2 by 3. In the place of x, I want to substitute 1 plus epsilon. 1 plus epsilon minus 1 power 3 by 2 plus 2 into root of 1 plus epsilon minus 1. Plus 1 and minus 1 cancel. Plus 1 and minus 1 cancel. Now write down the remaining terms. The remaining terms are 2 by 3, 1 power 3 by 2, 2 minus 1 is 1, root 1 is 1. 1 into 2 is 2. Here I am substituting in the place of epsilon 0. 0 power anything 0. 0 into anything 0. Root 0 is 0. 0 into 2 is 0. So thus after substituting epsilon equal to 0, these terms vanishes. So the remaining terms simplification is 2 by 3 plus 2. Take LCM, then it is 8 by 3. 8 by 3 is finite, hence the integrand is convergent and its value is 8 by 3. Next, test the convergence of integration 0 to 2 dx by root of 4 minus x square. The integrand has an infinite discontinuity at 2 belongs to 0, 2. That means if I substitute 2 in the place of x, then x square becomes 4. 4 minus 4 is 0, root 0 is 0. Anything by 0 is infinity. That's why at x equal to 2, the given integrand is having infinite discontinuity. That's why I am writing limit t epsilon tends to 0 plus 2 minus epsilon as upper limit, 0 as lower limit. Integrand is as it is. With the help of this formula, 4 can be written as 2 square, that means a equal to 2. Sin inverse of x by 2, the limits are 0 to 2 minus epsilon. First substitute upper limit, then you are going to get this term. Substitute lower limit, then you are going to this term. Upper limit minus lower limit. Here, after this step, substitute epsilon equal to 0. 2 minus 0 is 2. 2 by 2 is 1. Sine inverse of 0 we have. We know that sine pi by 2 is 1. That's why replace sine pi by 2 equal to 1 by sine pi by 2. We know sine 0 is 0. So replace 0 with sine 0. The simplification of this is pi by 2. The simplification of this term is 0. Pi by 2 minus 0 is pi by 2. We are getting finite and unique value. That's the given integral is convergent and its value is pi by 2. Next, test the convergence of integration minus 1 to 1 dx by x square. Here, observe integrand is 1 by x square. In between minus 1 to 1, in the real axis, we get 0. At this 0, the given integrand is having infinite discontinuity. That means 1 by 0 square is 0, then it is infinity. Now, I am going to splitting integration from minus 1 to 1 as minus 1 to 0 and sum of 0 to 1. So, observe this step. Here, I am having infinite discontinuity at upper limit. That's why 0 minus epsilon 1. Here I am having infinite discontinuity at lower limit. That's why 0 plus epsilon 2. If I have infinite discontinuity at upper limit, then I am writing 0 minus. If I have infinite discontinuity at lower limit, then I write 0 plus epsilon by epsilon 2. We know that integration of 1 by x square is minus 1 by x. Lower limit is minus 1. 0 minus epsilon 1 is epsilon 1. Same integrand. That's why integration of 1 by x square is minus 1 by x. Upper limit is 1. Lower limit is epsilon 2. Substitute. Apply the limits. Minus we have 1 by minus epsilon 1, minus into minus is plus 1 by epsilon 1. Substitute minus 1 here. Then also I am getting plus 1 upper limit minus lower limit. Here also first substitute 1, then you get minus 1. Next substitute epsilon 2, then we get minus epsilon 2, minus into minus is plus. Upper minus minus epsilon 2. So this is the simplification term after substituting limits. Now replace epsilon 1 with 0. 1 by 0 is infinity, minus 1 as it is. Here also minus 1 as it is. 1 by 0 is again infinity. So observe, here I have minus 1, here minus 1. Minus 1 minus 1 is minus 2. Infinity minus 2 is infinity only. So the given integration diverges to infinity.